Hi, I'm an old guy and I do maths. A student of mine was recently asked to explain the changes when this function is transformed into this function. What actually happens? Now, the first couple of parts of this don't give any trouble. What we can see is that the function is moved down 1 unit by this, and it's moved 2 units to the left by this. These are very common translations. The problem arose when checking the answer, and the answer said that there was a dilation of 1/2 in the direction of the y-axis. So what does that actually mean? Now there's a drawing here that very roughly, very crudely shows what went on. Now this shows everything. We've got the movement down here, and we've got a new asymptote here at -1, and we've got the movement to the left of 2 units. So this places this truncus over here from this point. But you may be able to observe from my poor drawing that this new truncus is much more slender than this one. And that is because there has been a dilation of 1/2 towards, in the direction of the y-axis, which means, of course, that this thing has been compressed towards the y-axis, or we could say stretched away from the x-axis, but this is the language we're going to use. Now, this is where the trouble started, and the question was, how could this be unraveled and explained? And you'll see that there's a little bit of calculation here. And what I did to explain this was I isolated the dilation. So I didn't worry about this and I didn't worry about this. So it is as if I was just concerned with, let me get this drawn properly, I was really just concerned with the dilation that did this. That's very crude again, but that's that. So what happens when this becomes this? What is the effect? Well, what I did was I thought, well, let's see what happens if we put a value into this. And the answer, of course, is unhelpful, because what we wind up with is we have 1/2 squared, which gives us 1/4, and we then have 1/4 times 2 squared, which gives us 1/16. That is essentially unhelpful because we're not looking at a movement in this direction. Essentially, what we wind up looking at is a movement in this direction, which is not what we're interested in. So what I did to try and demonstrate this to the person concerned was I took a point on the x-axis, the same point that I'd taken for these two examples, and put 2 into this equation, and I got 1/4. Now what I really wanted to do was to wind up in the same horizontal plane vis-a-vis the axis here. So what I wanted to do was to find a number using this altered function that would give me 1/4. And it turns out that if I want to make this equal to 1/4, the answer is that x must equal 1. So, what has happened? From the point of, let's do it on here, from the point of 2 here, if I put 2 into this function, I get 1/4. If I put 1 into this function, I get 1/4. This is wildly out of scale. But what it shows me is that there has been a dilation in that direction of 1/2. 2 has become 1. And that is the explanation for why there is a dilation of 1/2 in the direction of the x-axis as part of this general set of changes. So just to go over these again, this moves this down 1, this moves it 2 units to the left, and this is a dilation of 1/2 in the direction of the y-axis. I hope that this made some sense and allowed you to see how these things work. This is not, I stress, the only way in which this can be done. But I hope that my pupil found this an understandable way of getting her head around it. Thank you very much for watching. If you found this useful, please like and subscribe, and I'll see you next time. Bye.